way up through graduate level. And over the past 4 years since my postdoc, I've been working in life sciences consulting, academic strategic planning, and program management for research and education. So I thought I would take this opportunity to kind of introduce CCB. The seminar series is relatively new, and so this way we can introduce what is a Center of Computational Biomedicine. So we are a resource for computational education and expertise. And So we were founded in July of 2020, so we're relatively new to campus. And our mission is to leverage data and computation to transform research and improve health. And we achieve this by developing computational tools and applications and offering expertise through project collaborations with our HMS colleagues. We also offer computational education and skills training, which I'll discuss in detail today. And I'll send these slides around to everyone, and I'll invite you to check out our website where you can find out more information on the types of projects we're working on, upcoming events in education, and the resources that I'll talk about today. Also including my email. Please feel free to reach out with questions anytime. Right, so without further ado, so we can dive into the focus of today's talk, which is filling in the gaps, CCB's collaborative role in computational and quantitative education at HMS. So you may know that the scope of this seminar series is current developments and outstanding challenges in computational biomedicine. So today I'm going to talk about some of these challenges and in education and skills training, and explain how CCB is working with several groups across campus to address this need for our HMS colleagues. So computational biomedicine is transforming how biologists do research, which is rapidly evolving to include more data science. So in particular, innovation in genomic sequencing and big data are major drivers of this change. In particular, the genomic sequencing impact is due to partly due to technological advances in instrumentation, compute power, and hardware. This is just a fun statistic from 2016. The Illumina HiSeq platform was able to generate 4 times the number of annotated nucleotides stored in GenBank. Huge improvement from the early days of the Human Genome Project in less than 3 days, which according to GenBank was about 100 billion bases at that time. Another factor contributing to the genomic sequencing impact is cost reduction, but I want to be very careful here because it's very difficult to predict the cost per genome of sequencing analysis. However, the NIH predicts that it's gone down from around $100 million per genome in 2001 down to around $1,000 per genome now in 2016, and it's pretty much leveled off over the last few years. But that's again, that's not considered, that's subject to what factors are included in that. But the point is that this is making genomic sequencing more accessible to more researchers across the field. Another impact contributing to this evolution into data science is big data itself. So there's increased availability and accessibility of data sets from many sources, including phenotypic data from such as patient medical records and clinical trials, imaging data from microscopy and medical scanning, interaction data such as biochemical, cellular, physiological, and ecological systems, also from translational fields, bioengineering, material sciences, and biogeography. And another huge impact that big data has had is that it's drastically increased the complexity of this type of analysis. So this is because we're needing to integrate data from different systems and also integrate the known biology into that analysis to really interpret those results. And so ontologies and knowledge representation are some of the tools and the method that we use to integrate for this integration. And CCB has one of our groups, the working group at CCB is focusing on this, building a tool for our colleagues to use. So all of this is to speak, what does this have to do with education? So all this is to speak to the growing gap between the availability of big data and biologists' ability to analyze it. And so in the earliest days, when these kinds of methods were just coming out, and we needed infrastructure. That was the most pressing need, back in the early 2000s. Around just about 5 years ago, the technology has drastically improved, and so we have high-tech security, high performance compute power. We've maximized storage capacity, and hardware has greatly advanced. These things aren't perfect, of course, but they're in a much better place than they were 10 years ago. And so now the focus is sort of shifting to where the greatest need is for education and tools. And so this is going to include modifying existing tools. So biologists have always needed statistics and data management, but now that we have this new technology, we'll have to modify our approach to these things in order to align with these new advances. And then also we need to provide training in bioinformatics and computation and programming itself, since those are the skills that they'll need to analyze these data. So there was a 2016 survey actually asked over 700 National Science Foundation principal investigators from biological disciplines across biology. This included bioinformaticists and also general biologists. And they asked about their current use, anticipated future requirements, and the institutional support they would need regarding computational elements for this kind of data analysis. And so what's interesting is that 5 years later, CCB also ran surveys. Didn't know about this study at the time, but we ran surveys asked of our HMS graduate students and postdocs back last year in 2021. And we asked about their anticipated need and also current skill level in various skills of computational science, bioinformatics, data management, and statistical analysis. And so I didn't see a follow-up study or a follow-up survey to this 2016 survey, but what I can say is that their predictions were largely aligned with what we saw 5 years later in 2021 from our postdocs and grad students. So back in 2016, nearly 90% of bio PIs said that they currently are or would soon be analyzing large data sets. And in 2021, our HMS postdocs, of all of the respondents who answered our survey, not a single one checked no, that they don't need any of these skills, talking about computational science, bioinformatics, and data management. So it shows the need for these education in this space is only growing. So what kinds of computational skills are needed? So there's a big range of things needed across disciplines. So this includes multi-step analysis workflows or pipelines, high performance computing, training and integration of multiple data sets. And however, this isn't shown in this graph, but from this same paper, the majority of the PIs surveyed across all disciplines said that their institutions are not meeting 9 out of 13 of these needs. This was back in 2016. And that the most pressing unmet needs were for training in things like data integration, data management, and scaling analysis for high performance computing. So we saw similar needs for specific skills in our postdoc and graduate student survey. We can see that we asked about current programming skills, and our HMS postdocs said that 20 to 28 of them indicated that their current programming skills are not sufficient for their research needs, and an even larger, some 20 to almost 50% said that they're either novices in these skills or they've never used these skills. And these are things they need for their research. So this is speaking to a big gap. We also asked them about, in addition to programming, we asked them about computational biology, bioinformatics, and data management skills. And you can see that the need was this is the vast majority of postdocs needed each of these skills. And also a concerning number, 20 to 50% did feel their current skills are either basic or not sufficient. And even worse, 9 to almost 30% in some cases said that they'd never used these skills that in the previous question they indicated that they needed for their research. And so this leads to the first challenge that I want to mention in computational education, is that the general introductory training will provide foundational knowledge in a programming language or a certain skill, but often it falls short in teaching the specific analysis that an immunologist needs for their specific data set, or that the geneticist needs for their specific data set. And so oftentimes folks will attend these workshops, and while they're learning great foundational competencies, they're still maybe not able to analyze their data. They're not able to go back to the lab and analyze their data after that workshop. Another challenge that I want to bring up is the variation between investigators. So if we think about this gray arrow here as closing the gap for to obtain sufficient foundational knowledge and skills in computational and data science in order to do research, then you can imagine that the need is going to vary based on career stage. So I graduated from college in 2007, so I know that as a biochemistry major, I took math through calculus 2, but I didn't have a single programming class. And so I'm just rough estimate surmising that anyone who graduated from their formal education before 2010 probably had minimal, if any, computational training in their formal educational program. Conversely, as the Human Genome Project wrapped up and then technology started to advance to what we're seeing today, there have been varying degrees of computational education. So for example, my graduate program, I was taught programming in my graduate program in 2013. And so that gap, you can imagine, is going to be very different from someone who never had any computational education. And then in the future, as the academic programs incorporate and standardize computational education and training for biologists, then the need is going to continue to shift towards keeping up with advanced technologies, of course, but less so about perhaps teaching that like foundational computation knowledge that biologists have been missing up to now. So this leads to the next two challenges I want to mention, which is that there's a high variation in foundational knowledge among biologists, and that the needs are going to continue to change as technology advances. So this speaks to a drastic need to constantly evolve, make sure our education approach is evolving so that we can continue to meet the needs of our constituents. So HMS has so many groups that are, so many groups have been established to help address this unmet need at HMS. This is not an exhaustive list, but this is an initial list of some of the groups that CCB is currently working with on several education initiatives that I'll talk about in a few minutes. So I just want to point out, I think Shannon is here from the Harvard Chan School of Public Health, the Bioinformatics Core. And so there are so many resources for computational education and skills training. However, we're still not able to meet the need of all of our graduate students, research staff, and postdocs. And so I believe Shannon was going to kind of share some of the challenges that HCBC has had in this area and kind of illustrate how CCB is working with them to address these.
Yeah, hi, thank you for that, Jacqueline, and hello, everybody. So the Harvard Chan Bioinformatics Core is situated at the Harvard School of Public Health, but we are also the dedicated Bioinformatics Core for Harvard Medical School. And we run a dedicated training program that actually is geared mostly towards postdocs in the community. We do have a component that is aimed at graduate education, but I think about 80% of the students in our classes are postdocs in the community. I also just want to mention that I'm speaking on behalf of Radhika Katani, who is our Director of Training at the Harvard Chan School of Public Health's core. So she wasn't able to make it today. So some of this is a lot of discussions that she and I have had in trying to strategize how best to meet the computational needs of the community. And what we recognize is that, in order for people to be able to analyze their own data, there's some basic analysis skills that are needed. And then on top of that, expert or more advanced courses that are required to allow them to apply those techniques to their own domains. And so because we are very much a sequencing focused core, a lot of our courses focus on applications of high throughput sequencing like transcriptomics or variant calling analysis or epigenomics. And so what's interesting is that the two basic courses we teach, there are an introduction to the shell or command line analysis. And lots of people understand, like when you say that, when you ask people what they need in terms of bioinformatics, they understand that they need R because it's a primary language for doing statistics and being able to understand your data. But not everybody understands that they need to be able to use the shell as well and to be able to use a high performance computing environment to analyze big data. And so, within our own courses that we teach, we often have long waiting lists for our workshops, clearly showing that there is demand for skills in R. But our shell workshops, they are full, but there's certainly not as much in demand. And when we move on to the advanced topics like single cell RNA sequencing or ChIP-seq, we note that people sometimes have these gaps in being able to use the command line. And so the other interesting thing is in direct relationship to the survey that the CCB did last year, Jacqueline, which is the observation that many people in the community had never heard about our training resources. And so we put on courses monthly for the community that are accessible to the Harvard community. And we must be doing something wrong in terms of making people aware of that these resources exist, or there's just a lack of visibility in general. And so I think that's a challenge that needs to be addressed, because I think part of the problem is that people just don't know where to go when they actually need some of these resources. And so, we're excited to be working with the CCB and HMS Research Computing and several other groups across Harvard focused on education, to be able to strategize how to scale up and to be able to reach more people in the community. And I don't know, did you have any specific questions or anything else you wanted me to address today, Jacqueline?
No, that's perfect. You actually teed me up perfectly for what's coming next. So thank you for that, Shannon.
Great, thank you.
Thank you. Yeah, so I'm so glad that Shannon brought up the example of the command line, because I feel like that's a perfect example of the kind of foundational knowledge that I was mentioning before, which is that, those of us who graduated a little earlier maybe weren't taught that, but as time goes on, that, those foundational computational skills are being more integrated more and more into biological curricula. And so, so in addition to all these Harvard resources at Harvard Medical School, and again, this is not, there's I've got the link to the core facilities list here, which lists so many more resources. But there's also support from external sources from the bioinformatics community. And so you can imagine that for someone who is just embarking on this kind of data analysis, it could be very confusing in terms of, what do I use? Which one is appropriate for me? And so Shannon spoke to this a little bit in that folks aren't aware of what's everything that's available, and that as she was, so it wasn't just Shannon's group that postdocs said they had heard of. It was actually, I'd asked about several groups, so not to single, if they're doing something wrong, then everybody can improve in that area in terms of making themselves more visible around campus. But so also, in addition to that, we also need to have some way of explaining to people what is the appropriate resource for their particular needs, because there are a lot of works, there are like 3 different intro to R workshops, and one's from research computing, but that's, how to use R on the O2 on O2, but the HCBC Intro to R workshop is, 4 sessions over 2 weeks with homework. So they're very different workshops that might have very similar names. So just to summarize, so these are some of the outstanding challenges in computational education and skills training. And again, this is by no means an exhausted list, but these are some of the challenges that CCB is working to address. And so again, and these are mostly due to the dynamic nature of data science and making it very difficult to streamline this kind of education. So we need immediate support and training for imminent data analysis. Again, as Shannon mentioned, those intro courses will teach, the basic skills of how to use R, but that may not help with their specific data analysis when they get back to the lab. Also, as technology continues to advance at this rapid pace, we need to make sure that our education programs are keeping up with that innovation. We need to consider the fact that biologists themselves will be highly variable in their what they know and where they are kind of on that spectrum. And then also with so many resources, we need to know which option is appropriate to leverage for you. And so this is where CCB comes in. Our education mission is to enhance computational education at HMS for students, postdocs, research staff, and faculty. And so our approach for doing this is to offer several solutions, including, but not limited to, things like options for just-in-time education. So this is that example that I keep mentioning about, the person who has a set of data that they need analyzed right now. Maybe they can't wait until next month's workshop, or maybe they can, but they can't wait 2 months and they're on the wait list and weren't able to get into that workshop. So we're brainstorming ways for how CCB can provide this kind of imminent education and analysis. We also want to help optimize the course structure and approach so that we're using self-directed courses, but offering assistance. So currently, most of the options are either learn at your own pace or attend a workshop, either virtually or in person. And so we're exploring options of hybrid models of those where folks can learn at their own pace. So they're not, as I think we can all agree, grad students and postdocs have the least of which they have is time. And so very often the schedule of the workshops isn't going to work with their course schedule or their research. And so we want to offer the self-directed option, but then also in parallel offer some sort of assistance so that folks can really be active participants in their learning and make sure that they understand. And then lastly, we want to focus on, very specific micro and mini courses. So CCB is not, our intention is not to have semester-long courses that are, part of an educational program on campus, but we're offering, mini and micro courses about specific skills trainings or, specific tools that are coming out and different kinds of things of that nature. So our approach for doing this is to first identify the gaps in current sources, and that's where our surveys come in that I'll talk about in a minute. And then we want to use that information to increase capacity and access of the existing courses and workshops to fill those gaps. And then also we want to work with existing programs that perhaps they are doing these things, and maybe like CCB is just working to enhance those programs based on our survey findings. Also, we want to be sure to delineate which course or educational resource is appropriate for a given researcher. And last but certainly not least, throughout this whole process, we're constantly performing research on how we're doing and evaluating our performance. So we're trying, new approaches to the course structure, but evaluating that and comparing, like the success rate of that course versus, like a synchronous course with the typical structure that was always offered before. And so we do this through, pre and post assessment questionnaires, and then also monitoring metrics of attendees from which departments, et cetera. And then of course, our graduate and postdoc surveys year over year, hopefully will give us a good indication of our progress. So the surveys I mentioned, so we have annual surveys for graduate students, and postdocs, and we're hoping to eventually have something where we're surveying the incoming graduate students so that programs can make sure that their G1s are starting on all on the same level. So we collaborate with our HMS colleagues for the survey design to make sure we're asking about the right skills. We want to make sure that the information we get is going to be valid for our other colleagues on campus. So this is how we're going to identify gaps in current resources. We share the results with all of our HMS colleagues by putting them on a Shiny app, which I'll show a little bit later. So we share this with faculty, program administrators, curriculum fellows, other education stakeholders. And this is to provide them access with the data so that they can see how their students and postdocs are responding from their own departments and across the school, and use it for their own benefit, however it may be helpful. So then comes curriculum design, so this could be content that spans departments or tailor-made content for a particular department or a program, town hall, workshop, etc. And this is how we're going to optimize resources to make sure that we're meeting this need. So the surveys will produce an action plan that looks something like this. This is an example of our action plan from the postdoc survey from back in November 2021. So we asked about, again, computational science, bioinformatics, programming, and data management skills. So what this did was it gave us a list of what the most needed skills were in each of those areas. And then we were able to go and say, okay, what groups at HMS are teaching these skills? And then reach out to them, share our findings, figure out how to work together. And so this is what spawned the current efforts that CCB is involved in now for summer and fall 2022, which I'll describe in detail in a minute. So how CCB is filling the gaps within computational education at HMS through this approach. And so one of the things that we've done is we have a course catalog on our website that distinguishes one intro to R workshop from another, so that folks can have a direct kind of comparison. All of these other resources like research computing and Shannon's core at the HCBC, they're all really great with communicating with each other and linking back and forth between each other's websites, but there was no kind of one-stop shop of these are all the courses, the workshops that are available by semester. And so CCB has that on their on our website. And this is comprehensive course information from across HMS. And so this helps people identify what resource is most appropriate for their needs. The other thing is scaling skills workshops. So again, as Shannon mentioned, we're actually working with her group to pilot CCB's first attempt at scaling some of these skills workshops in the fall. And so this is going to be how we're going to increase capacity and access for all of our Harvard constituents. Hopefully we can better meet that need, and then also offer skills training for new technologies and tools that are coming out in the field, just on the edge of cutting edge research in this area. And then also, I just want to emphasize that we're constantly optimizing this approach again for computational training. So if we make one adjustment, it's like a true research, it's a true research effort to change one or two things at a time and really kind of step back and evaluate what worked, what didn't, so that we can maximize the value of this education. And then also providing supplemental resources. So our applications, so our working groups at CCB are very, very talented bioinformaticists, computational and data scientists, and they're creating applications and tools that will help HMS researchers conduct their biological, data analysis more efficiently. And also we have a town hall coming up, which we may have seen the announcement has gone out last week and this week to various sources to announce, new tools and technologies that we're exploring that are kind of like emerging in the field. And then of course we have this CCB seminar series where we invite speakers from all over the world to come in and speak to these challenges in specific issues in this area. So the crux of our education program is our curriculum fellow. So we are very, very excited to have Chris Magnano here. So he just started with us back in March, a couple months ago, but he's already hit the ground running. He's come in through the Curriculum Fellows program, and so he's integrated into that network. And we're really hoping that this will help, as Shannon mentioned, most people who are enrolled, most of their attendees are postdocs and not students. And so we're really hoping that having CCB having a curriculum fellow integrated in that program will help, increase awareness of what we're here to do. And then perhaps we can, increase the, get more students to come to these workshops or to be aware of these workshops through the program administrators. So Chris has extensive experience teaching biologists computational skills. He has a PhD in computer science, and the kinds of things that he's going to help us with are, measuring workshop success. So we do the needs assessments, before and after a single workshop, then also our annual surveys that I talked about. Again, I've mentioned he's doing active research to maximize the effectiveness of our teaching approach. So we're constantly trying to make that better. Using best practices and assessing the impact so we can have this continuous improvement in education. So our surveys, while they happen every year and we may have to make minor adjustments to adjust for changes in technology and things, but we're keeping them largely the same so that we can have some sort of comparison year over year of how HMS, how we're doing as a whole in enhancing computational education here. Chris is the one he'll be making sure our course lectures and materials for all of these efforts that we're talking about are easily accessible. And then also adding, as I mentioned, the surveys to an interactive application that we can share with HMS colleagues and track progress over time. And so this here is a link to the survey. So once I send these slides out, you should be able to access that if needed. But if you're not able to, just please email me and I'll provide access. So specific things that Chris and I are working on now for CCB's education initiatives for summer and fall 2022 is, again, we're scaling up one of the skills workshops that Shannon's group has long since been hosting. We have this seminar series, and then of course the needs assessment surveys. We're also directly collaborating with the Curriculum Fellows program and the postdoc office to try and establish a teaching certificate program for postdocs, and really we really want to do something for postdocs that kind of enhances their professional development. And so those are still in the early days of discussing what exactly that means and what the requirements are, but stay tuned for information about that coming out soon. And we're also working with the image microscopy and image analysis course to maximize image analysis education across campus. This was the biggest driver the biggest need by far that came out from our survey was image analysis and processing. So speaking to Shannon's mention of, people not the kind of low level of awareness of the different resources on campus. So CCB, first of all, CCB has several things coming. So in June 2022, we have a town hall to introduce a new tool called AlphaFold for predicting protein structure and complexes. Have a look out for our graduate student survey, which will come out by the end of June. In fall 2022, we're planning a CCB open house, which will have more detailed information about not only our education efforts, but also our project collaborations or working groups, and more information about what CCB can do to help our fellow researchers and how to how to reach out and get in touch with us about starting a project. Again, I'll invite you to visit our website and learn more, and you can always email me with questions. These are our current, again, CCB is new to campus relatively. July 2020 was when we were here established. So we're still kind of finding our footing and what's the best way to reach our audience. So our current avenues of advertising are through the Curriculum Fellows Program, postdoc office, the Biological Sciences Administrators Group, advertise on my HMS, through the DBMI Slack channel and website, of course, through our website. And I would love to hear if these are the best ways to inform your group, or if there's something else that we can do to really get the word out about what CCB is doing. And the other thing, lastly, I just want to highlight I can't overstate the value of the input from our community in making sure that we do our job well. So we need the input from graduate students, postdocs, faculty, administrators, all of our groups around campus to make sure that we're designing educational programs and focusing our project, having staff on hand for project collaborations that have the expertise that will really be able to help our HMS colleagues in their research. And so ways that we can, that we seek feedback is, again, through the surveys, this CCB seminar, we send out department emails through the administrators list, various HMS newsletters, BioGrid's Technologies Breakfast, our website, and of course, you can always email me directly or Robert or any our directors who to offer suggestions for what we should add or how we can make our program better. So with that, I want to thank the CCB team. This has been so much fun working with this young center. It's very much a startup family community, and there are a lot of gray boxes here because we went from 7 people to I think 13 in a span of 2 months. And we have 2 others joining in the next few months as well. And so I just really, this is a great family, and I'm so excited to be involved in, and thanks so much for all of your hard work and support. And with that, I'll take questions.
Nice job. Very nice job. I'll just go because I just been bowling here. But you mentioned that we have education for graduate level and postdocs right there. Is there any interest in undergrads or K-12 outreach?
Not in these early years. We're going to get our feet under us first on the HMS quad and really focus on meeting the needs here with our students and postdocs. But Robert and I are definitely interested in outreach that will, help those younger generations. But we're just not haven't gotten to that yet. Right. Okay. Well, if there are no questions, Ludwig's not here, and he's normally running this. So again, I'm happy to send out the slides to everyone with all the links to our website and email and all of the information that I shared here today. Okay, thank you.
Bye.
Thanks, Jacqueline.
Thank you,
Jacqueline.